Let's take a look at today's map. Today we are doing some graphing. So we've learned about adding and subtracting decimals, how the most important thing is that we line up those decimals. We've learned about rounding decimals, and I think the most important thing is knowing the place value positions. Hang on, guys, someone's talking. The most important thing for rounding is knowing your place value position, so you know where you're rounding to.
Literally.
Okay. And now we're going to look at some graphing with decimals, which is the exact same as graphing with whole numbers. We are on page 55, lesson 2-9 in our student activity book. Let's get to work. So this type of graph is called a bar graph, right? It's a graph, it's got data in it, and the data is marked by these bars that rise up. Bars can also go horizontal, they can go left to right, okay? So the first question, what is the length of the bark beetle? Well, underneath here we see the bark beetle. We need to see how far up he goes. Well, you notice that our scale, and our scale is the numbers that go up the side. The scale only has the even numbers. It's every 2/10, 2, 4, 6, 8, 10, and so on. So those go by every 2/10, but there is a line in between. So what would be between 2/10 and 4/10?
0.3. 0.3 tenths.
So let's think about how to say it, guys.
0 and 3/10.
Thank you. 3/10. Yes. Is my answer just 3/10? Is that it? Is that all I need to write?
No.
3/10 what?
Inches or centimeters.
Centimeters. Yes. Right here, it's telling us this is the length, and it's saying it's the length in centimeters. It's telling us how it's measured. So 3/10 centimeters. Make sure you're labeling those answers. All right, next one. How much longer is a firefly than a bark beetle? So we have to figure out a firefly. How long is a firefly, everybody?
1.3 centimeters.
1 3/10 is a firefly. Yes. How long is a bark beetle?
0.4.
4/10.
3/10. Thank you. We got to get over this 0.3.
It's
3/10.
4/10.
Am I going to add or subtract?
It's 4/10.
I'm going to subtract. Yes.
Oh,
1 and 3/10 minus 3/10. Notice I lined up those decimals. 3 minus 3 is
0.
0. Put in my decimal. 1 minus 0 is
1.
1. What's my answer?
1.
1 what? 1 centimeter. Yes. Okay.
For a second,
Estimate. Question?
for a second, I thought that it meant like the bark beetle was like, or like the firefly was like a couple of I don't know. I thought it was a couple of centimeters. I thought that's what this was implying, and I know that's not true.
All right. Ashlyn, I see your hand is up.
How do you know if it's inches or centimeters?
Because it says length in centimeters. That IN in this case means in. It's not the abbreviation for inches. Length in centimeters. Okay.
That's not
Estimate the length.
confusing.
What was that?
I said that's definitely not confusing at all.
Right. All right. Estimate the length of a tumblebug in hundredths of a centimeter. Well, a tumblebug, look at him. He doesn't end right on a line. He's right here in between. So this line is our 8/10, right? This is our 9/10, and this is 1 whole. He looks like he's halfway between 9/10 and 1 whole. What number would be halfway between 9/10 and 1 whole?
0 and 95 hundredths centimeters.
Oh, I love it. 0 and 95 hundredths centimeters. Yes, right? If we have our number line and we have 9/10 here and 1 whole here, and we want to go halfway. This is 91, 92, 93, 94, 95, 96, 97, 98, 99, 1 whole. Perfect. The actual length of one beetle shown is 150 thousandths of a centimeter. Which beetle is that?
Firefly.
I hear 1 vote for firefly. Any others?
And ladybug.
Firefly.
Fly.
So the firefly, hang on, let's look at this. The firefly is more than 1 centimeter, isn't it? This number starts with a 0. So the firefly is way too big. We want something, and we can take this last 0 off, right? We can forget about that. We want something around 1500ths. Yes, the seed beetle. Because right here is 1/10. Right here is 2/10. And he's halfway between 1/10 and 2/10. So it is the seed beetle. All right, the last one says a June bug is about 2.5 centimeters in length. Notice how I called this 2.5. Do you guys know why that's 2.5?
Because 0.5 is right in the middle, or 5/10 is right. It's like right in the middle, and if you round it, it also goes up. So that really doesn't apply.
It's 5/10, right? 5/10, which is also equivalent to 1/2. So anytime it's 5/10, it's a half. So a June bug is about 2.5 centimeters in length. About how many times as tall as the tumble bug would the June bug bar be? So how many tumble bugs would I need to get to a June bug?
1.5.
So let's think about that. A tumble bug is less than 1, right? A tumble bug is less than 1.
Yeah.
So, but a June bug is 2.5 tall. So I would need to go 1 tumble bug. That gets me to about 1.
About 3.
I need another tumble bug. That gets me to about 2. And then I need about a half. You guys see that? So it is about 2.5 bars. Round whole numbers to help you estimate. Yep, I would need about 2.5 bars, 2.5 tumble bugs to get to a June bug. All right, let's see what Puzzled Penguin has going on. Dear math students, for the science fair, I recorded the heights of several plants a month after I put different fertilizers on them. I made a bar graph of the data. Did I make my graph correctly? If not, how can I fix it? Look at his graph. What do you notice about his graph? What might he have done right or wrong?
You start with a hole after the 0.
Okay. Does anyone else have a thought?
He missed the 1.1 and the 1.2.
Okay, so so we mentioned how this right here is called your scale. Okay, every scale has an interval, and the interval is the difference between each number in your scale. And if you notice, we have 1/10 difference, 1/10 difference, 1/10, 1/10, 1/10, but then I get to 3/10 difference. And then I get to 1 whole difference. You can't have that. Your interval needs to be the same throughout the whole scale. Now, saying that, there is one little trick you can do. So if I didn't want to include everything between 0 and 1, and if this over here was my scale, I could put this little like crooked line in here and put my 0 here, and then 1, 1 and 1/10, 1 and 2/10, 1 and 3/10. Because this might just take up a lot of extra space if I put all those numbers from 0 to 1. So you can put a little crooked line, like a little lightning bolt, And that means that you're gonna remove some of the numbers, but you have to make sure that your interval is the same all the way up your scale. Okay, so that's what his error is. His interval was not the same throughout his scale. Okay, you don't need to write anything on that. I just wanted to talk about it. Let's flip to the back. All right. Make a bar graph with decimal numbers. So last week, a chemist kept track of the masses of the different samples he tested. The box on the left shows that information. Use the box on the right to make a list that shows each mass rounded to the nearest hundredth of a milligram. So notice these are all in thousandths, tenths, hundredths, thousandths right now. We need to round each one to the nearest hundredth. So I want you guys to do that. I'm gonna pull my book away and I'm gonna do it too. So I'm gonna do the first one with you though. So I'm gonna underline my 3 because that's what's in the hundredths place. I look behind that 3 and there's a 6. What's that 6 gonna do to my 3?
Round up.
It's gonna round it up to 4.
Round it up to a 4. So my 0 stays the same. I have my decimal. My 1 stays the same. And my 3 changes to a 4. And I don't need to put anything after the 4. Okay? You guys finish rounding out B through G. I'm going to pull my book away and I'm going to round 2. But I'm going to give you guys 1 minute to round all those numbers. Go for it. And I'm good with you staying away from the edges, and I can go back and get the edges. Well, and you might open the door when you're doing edges. Oh, yeah.
Done.
Give you about 20 seconds. Excellent.
Done.
10 seconds. 4, 3, 2, 1. All right, there's my numbers. I have 1400ths, 1700ths, 1300ths, 1200ths, 1800ths, 1600ths, and 1100ths. All right, hopefully you guys did okay with that.
I added a 0 to the end.
Okay, you don't need it. It's just extra if you have the 0 on the end. It doesn't change the value with the 0 or without the 0. All right, so which sample had the greatest mass? Which one of these is the biggest?
Sample E.
Sample E, my 1800ths is my largest number. That's my greatest mass. Sample E. Which one had the least?
Sample G.
Sample G.
Sample G, right? That's my smallest. And to compare these, you can just get rid of the 0 and the decimal point, and then look at that. They're all just numbers in the teens. I have 11, 12, 13, 14, 16, 17, 18. Those are easy to compare, right? Don't let these zeros and these decimals scare you. Estimate the total mass of the samples to the nearest tenth. To the nearest tenth. So now we're going to round them to the nearest tenth. So 1400ths is close to 1/10. 1700ths is close to 2/10. Go ahead and figure out your tenths for the rest of them.
It's triplet.
All right, once you've done that, estimate the total mass. So now that I have these, I need to add them together. Ashlyn, I see your hand is up.
On sample F, I got a different answer for the first rounding.
For the first rounding?
Yeah.
So sample F has a 6. Go ahead.
I rounded down because I got 0 and 1500ths.
Okay, this number never gets smaller than what it already is. It's either going to stay a 6 or it's going to go up. It's never, never, ever, ever, never, ever going to get smaller. Okay. All right, so now I need to add these together. 2, 4, 6, 7, 8, 9, 10. Well, 10 tenths is the same as 1 whole. So my estimate of the total mass is 1 milligram. Okay, and now we get to draw a bar graph. That's the best part. And they have helped us out greatly by already putting the scale with the interval on the graph for us. So sample A is 1400. So I'm just going to draw a bar that ends at my 14. 1700ths is sample B. Okay, finish out your bar graph. There's mine. We do okay on that?
Yes.
Okay, I'll give you guys about 10 more seconds to finish this up because having this graph is going to make number 12 so much easier. So much easier.
Done.
All right. So number 12 says write the sample's masses in order from least to greatest. So what's my shortest bar?
G.
G is my shortest, right? And that is 1100ths. What's my next shortest?
D.
D, which is 1200ths. What's my next shortest?
C.
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 C, which is 1300ths. What comes next?
A.
A.
A, 1400ths. What comes next?
F.
F, yep, all the way over to here, which is, let me go, 1600ths. What comes next?
B.
B.
B, which is 1700ths. What's my last one?
E.
E.
E is my greatest at 1800ths. Okay, your homework page for today looks very similar to what we just did. And I will stay on if you want to work on this together or if you have questions on some of the other math that we've done. But you have a graph here that you're answering some questions about. And then down below, you are creating your own bar graph. And on this one, you're going to have to create your scale. In fact, let's think about our scale together right now. So when I look at my numbers, I have 500ths, 1/10, 2/10, 2500ths. What do you think my interval should be? What should I count by? So I know I'm going to have 0. What should this first one be?
5.
5? Like a whole number 5?
No, 5/10.
5/10.
5/10? Oh, these are
500.
oh,
500ths.
Yes, 500ths. I get that. How about my next one? What should my next one be then?
0 and 10 hundredths.
10 hundredths, yes. What should my next one be?
0 and 15. 0 and 15.
15 hundredths, yes. But I don't have a number on here that's 15 hundredths. Do I have to put it down here? Yes.
No, you can use
Yes,
this.
I have to put it because if I don't, my scale is not going to have the same interval. What comes next?
0.2
hundredths.
20 hundredths. What comes next?
0 and 5 hundredths.
25 hundredths. Awesome. Do I need to keep going?
No,
No,
because
that's
that's
that's here. Okay. And then the back side is just more practice. Ooh, look at some multiplication. I think they're getting us ready to multiply decimals. Associative property is just that regrouping. So just move your parentheses around. Some estimating and a chart on stretch your thinking there. You just need to create your own math problem is all you need to do. And it needs to be a two-step problem. So maybe you add and then multiply or add and then subtract. Okay. A two-step problem is what you're doing for stretch your thinking. All right. When you're finished with your math, I would suggest studying your Greek and Latin roots, studying your parts of speech, because you are going to have those tests coming up after break. Hang on just a second. Don't leave me yet.